Oh, okay. So fine, let's start. So as per the details I shared from our PowerPoint slide, that after the simulation, we are going to generate the process flow diagram of this, right? And I told you guys that we are going to generate it through AutoCAD, send this file to AutoCAD. That's one. Two, we are going to generate the heat and material balance as stated. I'm going to share a line sensor heat and material balance. And okay, before I go to the heat and material balance, I'm going to share some process flow diagram of line sensors for you guys to see, have an idea how it looks like. So after that, we'll move to the heat and material balance. So we'll move to the heat and material balance. We'll now see the process conditions or the parameters or the data in this our heat and material balance. I will now tell you what we use this data to do. I will now relate this data to a standard. So I don't know where I'm sure that we have some people in LNG Bonnie here. So I'll be sharing a share code and standard. Please, if I'm wrong, correct me. Share is the one in charge of the operational aspect in LNG Bonnie, right? So if they are the one in charge of the operational aspect in LNG Bonnie, most of the standard they will be using there will be that of the share. So anybody that is an LNG Bonnie can correct me if I'm wrong with respect to that. So I'll be sharing share standard, relating it with what we are doing or what we are going to be doing now. So moving forward, let me just show you this is the procedure on how to send this file to AutoCAD. So what you just need to do is easy. Right click on this your flow sheet area. Then you see what, let me go up. Hold on. So this is blocking it. Let me take it up a bit. So right click, go to print PDF to file. Then anybody that have used AutoCAD, we know that the file type name of AutoCAD is what? DWG. But we also have, whenever you are exporting a file from any other software to AutoCAD, those files are always in what? DXF. Anybody that's written AutoCAD International exam will have the user, we have the about four, right? User, associate, professional, and experts. I have the expert international certification for AutoCAD. So if you have written, I think professional, you'll be seeing questions like this. So, and again, sometimes process engineers, mechanical engineers, we use AutoCAD. I have worked as a project engineer. So we use AutoCAD in our EPC, in our construction, EPC aspect. When we are generating the piping ISO, we want to update the piping ISO. I want to develop our cut sheet drawings from our structural fabrication and so on and so forth. We use our AutoCAD. So most times you see process flow diagram, we will say, no, 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 I don't do anything with respect to AutoCAD. It's just IC simulation. I'll be doing sizing, go to my detailed design. No. When we are talking about drafting the process flow diagram, it's just recently that we can generate our HYSYS file. About 4 or 5 years ago, we can generate our HYSYS file to AutoCAD. Back then, when we are using HYSYS that you need to go through other windows, we don't have such way. So what we used to do was to use our AutoCAD, draw our, what's it called, process flow diagram from the simulation that we have done. But still, that doesn't mean that process engineer doesn't use AutoCAD. We use AutoCAD in our P&ID drafting if you want to develop your P&ID. So there's a difference between P&ID design and P&ID drafting. Take note. P&ID drafting is when you are using AutoCAD to be drawing those things. P&ID design is when you are not sizing all those PFG, all those control valve, all those necessary gate valve, back valve, doing the necessary sizing and designing aspects. So take note, there's a difference between drafting and design. So we are going to send this file now to AutoCAD by using this method. Just come over to your flowsheet area, right click. I will be a bit fast because I will see how we can cover a lot and discuss about the plan for the next. So I'll just come over here, come over to print to DXF file. Then look at it, it's showing me DXF file. I can name it anything I want to name it and come over here, save it. When I save it, I'll go back to that folder where I saved it. Where is it? PDF, look at it. If I double click on it, here it's showing AutoCAD drawing. When you double click on it, if you have AutoCAD on your software, if you have AutoCAD software on your laptop or your desktop, automatically when you click on it, it's going to open. So let's see how it's going to be now. So imagine, let's say how it's going to look like. Imagine you are now using your AutoCAD to be drafting this from the beginning. It's going to take time. But imagine what you are going to see now. Let me go here. So this is it. So that's why sometimes you see some drawings, you see that the font size, everything are equal. You see that the arrows, everything are equal. Most times, people that use AutoCAD too can also do something like this and copy and paste everywhere. But imagine how I made life easy for myself, right? But let me explain. If you want to do this design or if you want to convert it to a process flow diagram, we don't just make it long like this, right? Maybe, let me assume when I'm doing my simulation, just that we don't have time, I could have rearranged this very well. When we stop here, we can take this, go like this, then move it to like this. So not just make it long like this, because this is just conceptual design. But when we are now doing the refit design, that's the feed, when you are doing the front end design of the simulation, you can make it long because it's going to be very, very long, right? So you can make it long, but not just straight. You will see it to go straight, come up, go like this, go up again, go like this, and so on and so forth. So this is how to convert your AutoCAD. This is how to convert your simulation file to AutoCAD. So this is what we call PFD. PFD is one of the process deliverables we generate from IC simulation. Take note of that. When you are done with your conceptual stage of design, before you move to your feed, one of the documents required, one of the inputs required in the feed design or in the feed stage is your process flow diagram. It's from this process flow diagram we are going to start to deliver our P&ID. P&ID in the sense that look at this compressor. As a process engineer, not just process engineer, as a senior process engineer, you must have the knowledge of the necessary instrumentations that will be around this compressor, depending on what this compressor is doing, the fluid and so on and so forth, temperature, pressure, you must know. So let me assume that you know, okay, let me go to this valve. Most of us will be familiar with that of the valve. So imagine this is this valve now. Let me assume that the purpose of this valve is basically for control, right? Definitely there's going to be some gate valve. If you are designing the valve to be fade to close, fade to open, there will be drain valves, there will be ball valve, gate valve around it. So as a process engineer, as a senior process engineer, you must have knowledge of this. So I'm not leaving the mechanical engineers behind. Mechanical engineers, when the process engineers are done doing this, they will give you the process conditions, which you will use to specify the material of the equipment or the fittings in the plant. So it's not that you guys are out. No, 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 no. We have what we call the multidisciplinary engineers in the facility. Everybody have the job they do, but to be sincere, everyone still wait for that process engineer to do the simulation, get the necessary heat and material balance for them to move on to the next stage. So let me just stop here. So this is how to do this. I'm sure if you know how to use AutoCAD, you can generate this and send and print it out in PDF. So let's just leave that for now. Any question before I move on to the next stage? Okay, fine. So the next stage will be hold on. Okay, I think there is some chat. Wow, wow, wow. So exactly. So the P&ID for that compressor will be singled out with operating details. Good, excellent. Ogenechiku, you have knowledge about that. Excellent. So now the next thing we are going to do, take note of this. We want to generate what we call heat and material balance. We call it HMB, right? Now, let me share or let me show you an example of what we call heat and material balance. Most of you may have seen it, right? So look at this. Let me see here now. Our normal vapor fraction, pressure, temperature, density, viscosity. After this viscosity, yeah, these are the what's it called? What do we call them? Let's confirm this. I'm coming. Just hold on. Good. These are the properties of the stream. So from pressure to the viscosity, These are the basic properties of the stream you need to show. So to be sincere, I have done a job with Technique, with Tencent Crop, Ado Topso. They still use the same heater material balance, the same conditions like this, the same properties are here. So that's that. So temperature, pressure, flow rate, these are the things you need to show. Then the next one is the components, the compositions of the components, right? The composition of the components. So for the composition of the components, you will see them you will see them around here. If you go to your composition, so we are even dealing with only three components. So our heat and material balance will not be that much compared to this one we have here now. This one we have here now. So let me just move direct by generating the heat and material balance. So take note, this is how we generate the material balance. We'll come to home, click your workbook, and come over to settings. Now, before I come over to settings, you will see that they have vapor fraction, temperature, pressure, molar flow rate, mass flow rate. If you scroll, you will see liquid volume, heat volume, right? As per the names, we have, as per the, what's it called? Okay, fine, that's that. So these are the properties you have here. But if you come to compositions, we have our nitrogen, oxygen, and argon. So what we just need is the composition and the properties as per what we have here. So some of these properties like viscosity and molecular weight, they are not here, and also density. So I'm going to teach you how to add these ones and how to remove those ones we don't have. So this is it. Come over to setup. When you come over to setup, do we need, let me see what we don't need here so we can remove them. Mass flow rate. Okay, we need mass flow rate. We don't need molar flow. So we can delete this guy. We don't need liquid flow. We don't need heat flow, right? So we need vapor fraction, temperature, pressure, mass flow rate, and what? We need density, molecular weight, and viscosity. So let me show you how to add those things. So you come over here to add. The first one there is density. You see density around here. Okay, supposed to be molecular density, right? Okay, let me check on that M. See molecular density. Okay, this is it. Molar density or what? I guess the normal density is not there. So I guess we can use the molar density. Let me see. D, under D. Go down have. So let's use the molar density. We'll click this and we click add. The next one over here is molecular weight and viscosity. So molecular weight should be around here. Molecular weight. This molecular weight, we click add. And the last one is density. No, not density. Viscosity, yeah. This is viscosity. Click add. So after we are done with that, we just click done. So we have it as per standard based on what line sensors are doing, right? So when we are done with this, you can just click, maybe if you want to arrange them order, but I guess it's in order. You can just close this. Oh, close that, confirm they are there. Vapor fraction, temperature, pressure, mass flow, molar density, molecular weight, and viscosity, right? So the next one is what? Composition is here. So when you are done with all these settings, just come over to Excel. Let's send it to Excel sheet. We don't need the energy stream. We need only material stream and the composition. Click these two. So depend on you, numbers of columns. I guess we should just leave it at, it depends. Let's leave it at 10 columns, B. Because you know we have so many streams, right? We have so many streams. Let me minimize. Okay, no. Let me go back. So depending on the number of streams you have, but now take note of this. See this heat and material balance. Is not all the stream we use to generate out. Because if you put all the stream, your heat and material balance will be complex. So at the conceptual stage of design, there is you just look at the most important stream which you need to generate out, right? So others you can kick them out. So you not make the heater material balance to be that just like now, if you look at this now, we need air. From this air to what's it called? Compressed air, cool air, compressed air, cool air, compressed air. If you remember, all what we are trying to do was just to increase the pressure of this air. So you can just click, use this air, use this LNG, right? So even this some of this bottom depends on you. You just look at what you think is very, very good and generate them out. So let me just change this to 10. 15 will be too much. So let me just click export to Excel. So if you have Excel in your laptop, automatically it's going to come up. So this is it. It's loading, 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 loading. Just leave it. Let it little time. It's going to load up. So if it finish, so this is it now. You can increase this here. Vapor, temperature, pressure, these are the units. So from here now, depends on you. You can remove all these guys because we are still using what we are trying to do was what? Increase temperature, increase pressure, pressurize the air. So you can remove all these. Just look at some other streams which are not really, really important. Remove them. So when you remove them, this is air, compressed air. The next one is the oxygen, nitrogen, when we are recycling back to the LNG heat exchangers, right? So take notes, all this to clients, to the storage, pure nitrogen, very, very important. You need to bring them up. Nitrogen boil off gas, you need to bring them up, right? So, and I think there was a project I did recently on LNG boil off gas just to recycle the LNG bottle of gas back. I need to design the P and ID. But before I design the P and ID, I need to go back to my simulation, redesign. I get the simulation from the company, check, get conditions from there, start designing and everything. No, not they already have a P and ID. They just want to optimize their tank. So when they're optimizing their tank, that's the storage tank, the amount of boiler gas will increase. So we need to also effect that in our simulation. And after when the volume of gas increase, maybe, I think, yeah, the pipeline taking that volume of gas out of that tank was even higher when we did the sizing of that line. So imagine what HYSYS helped us to do in order to generate other things. So this is our properties and this is our composition. So what I used to do is that I tell people that this sheet one, ICE just help you to bring it up here for you to bring up all what you need. So what I used to do was I will copy I will copy all this. I'll copy this now. Come to my sheet, paste it here. Under this composition, I will copy this composition. Take note of what I'm doing. Come over here, give one space down, paste it here. You will see that you will see that this is vapor fraction, right? Pressure, blah, blah, blah. You see how this is. You will see the other streamlines, right? So let's go back to our own Excel sheet. See the streamlines. See our necessary temperature properties and components. So this component, I always tell people that remove this, leave only this as per how we do it with licensors. Oh, what am I doing? So remove all this, even this too. So that's why I think someone contacted me the first day. After the first day we did this training that he wants to undergo the ICS training. He was asking me how many days. I told him 8 to 10 days, but take note, it's till we finish the contents, then it may still be more than 10 days. You must do your project. If you don't do your project, you will not get your certification. So this is it. We have done this. You can come over here, copy the next one. So the next one now, you just need to copy from here, right? You don't need to copy all of them as I told you. Paste it here, right? Come over the composition area. Just copy only this. Paste it here, right? So that's what you are going to do till you copy and paste everything. So imagine that we are doing this now and it's very, very long. That's why we don't bring up all the streams, only the major stream. Take notes. You will remove all this. Remove these guys. Make your heat and material balance to be short as possible. So if you see now, all these values in this blue color, they are the one we input. While the black color are the values that HYSYS calculate for us. Take note. So this is our heat and material balance. So as I told you earlier, we have a lot of things to do. So I just want to touch up everything. And before this is done, we are supposed to do the PFD. But nevertheless, this is our heat and material balance. So before I show you what we use heat and material balance to do, let me show you some line sensors PFD. But any question before we continue? I guess I'm too fast. I know I'm fast. Please, any question? Please, from the chat box, tell me if you I want to see who have knowledge of heat and material balance and what we use heat and material balance to do. Have you ever generated heat and material balance from HYSYS simulation before? If yes, if you cannot send the message quickly, you can just unmute and speak. Let's make it fast. If you
We
are
can use
not,
it for
let me see your
sizing.
reply.
We can use
Come
some of
again?
the we can use some of the properties of that stream for line sizing, right?
Yeah, excellent. Excellent. So whenever I want to start our line, we use all this. Look at this simulation now. Let me go back to the simulation. Okay, fine. As I told you earlier, this is the pure nitrogen, right? This nitrogen now is a pipeline going to the compressor, right? We need to determine the pipe diameter of this. And in the field state, as I explained to you, we use pipe segment around here. But in the conceptual state, we just use a streamline. But even with this streamline, I'm going to show you guys how to do a line size, and even in IC simulation. So moving forward, any other answer or contribution? I'm not seeing any chat. Is it that we don't know how to generate it and material balance? From our comment yesterday, I see that some people already know how to use HYSYS. Okay. Let's continue. So fine. Let me move on to the process flow diagrams. So this is take note, this is air liquid. So they are one of the line sensors. They are line sensors not just only for air separation heat operation, no. They are line sensors in so many other areas. Let me show you. Let me see how I can increase this. Now, if you look at this now, this company is the line sensor in hydrogen and syngas production, CO2 and sulfur. These are our air gas that we are dealing on. They are also line sensor in hold on, chemical and fuel, natural gas treatment, syngas, customer services, and turbo expander. So let's just move to what we are here for, which is what? Air gases. I guess there should be where I can put number. Okay, yeah, 44. So this is air gases. Have you heard of this company before? Please, I want to see from the chat box. Who have heard of this company before? This is a licensor. Yes, Tahil. Have you worked with them? Yes, good. Yes. Work with them, or you just saw them online? No, no. Okay, fine. No problem. So fine. Let's start with this. Let's start with this here. Just saw them. Okay, fine. Saw them online. Excellent. So this is one of their lines. This is one of their process flow diagram. If you look at this now, they are compressing the air, pre-cooling, boosting, co-production, the heat exchanger, which is the LNG heat exchanger, and this is distillation cooler, right? Now, maybe if we are doing a conceptual design, the first thing we will take note take note of is we must know the expected capacity of the plant from the client. Maybe the client want to be producing okay, fine. We must know the expected capacity of the plant. Maybe the client wants to be producing fertilizer, urea, or anything, or ammonia. Our own job as per separation unit operation is to know the amount of nitrogen required in order to meet up to that capacity of that plant as per what the client specified or what the client wants. So if you look at this now, they specify the capacities 110 to 380 tons per day. When we do that our calculation, I don't know. I will see if I have that Excel sheet in order to get the amount of nitrogen required for various facilities. I have it, you just look for it. So when I told you already, for like sensors, we don't do plenty calculation. We have a Excel sheet already, template for that. So when we do our calculation, we know the nitrogen required. If the nitrogen or the oxygen, see here, co-product. The main product for this is what? Oxygen. So this lines, this PO process flow diagram is basically for what? Oxygen production. The co-product are nitrogen, liquid oxygen, liquid nitrogen, liquid argon, compressed dry air. The capacity is what? 110 to 380. Let me don't go in depth explaining the process flow diagram. Let's go to another process flow diagram. I think I just passed one again. See, this is Yango. Yango is what? Oxygen. This is the purity, up to 50 bar. They will specify it. This is your other core product, right? The next one is what? Vacuum swing. Oxygen from this, 40 to 130. Another one is what? Product. See this one, our product is what? Nitrogen, right? Just our estimation we did. Co-product is what? Liquid oxygen, high purity. This is the capacity of what? The nitrogen, right? Good. So the next one is what? Nitrogen generation. So this one is also produced nitrogen. So if you look now, each line sensor we have a process flow diagram for nitrogen production, while other products will be what? Core products, right? So take note of that. Whenever you are doing your conceptual design, don't go and use a process flow diagram of a line sensor, which is not meant for that particular product or for that particular production you are looking for. If you use a wrong process flow diagram, that means you will be making a wrong engineering judgment. And engineers, when you make a wrong engineering judgment, there will be a big problem. Problem in the sense that if the client knows later on, it's going not just it's going to affect you, it's going to affect your company. I have done a project back then when I was in Nigeria. We did a project to the extent that my company was the EPC. We have the clients and we also have the PMC supervising us. The PMC did a very big mistake that we are the one that saw the mistake. The client just removed them from the PMC, then gave us both the EPC and the PMC. Imagine that. For we now, we'll be laughing. It's going to be a good thing for us. But for the PMC, they have lost their job. So again, there are some messages here. Set them online. Just set them go choose okay to learn and get HYSYS certification. Oh, so many messages. How to check the right licensor for crude processing facility. If you want to do that, let me just give you a knowledge. It's easy. Go online, check licensors for what's it called? Crude oil production. A lot of them are there. Corn oil, there are so many, right? Check them. When you check them, write them out. This is how we do research. Don't when you check them, write them out. When you write them out, let me assume that share, bring out share and say crude oil production PFD. Share crude oil production PFD. Put it online. Click so many links as soon as possible. If you don't see it, change the statement, change the words, change. It's going to be online. It's here online. If you cannot find it online, I will advise you guys to have account with script. SCROIBD. You will find a lot of documents there. A lot, thousands of documents are there, right? That's one of the easy place for you to get your licensors PFD. So again, Chuku, hope I answered your question. So, okay, these are all the process flow diagrams. We have so many. So this is just only one line sensor, right? This is just only one line sensor. We have
Sorry,
other line.
Mr. Majid. Yeah, can you take that again to get license? So where did you mention, please?
SCROIPD. Let me show you. Let me type it out. SCROIPD. This guy, this website is a good website, but I'll just advise you, the money is small. I think 17,000 naira monthly. You can start for free for the first month. Just go here, 17,000 naira. With that 17,000 naira, you'll be getting a lot of documents you need. Yeah, a lot of documents you need. If you see now, when I open this now, what is here is what? Riga 3 certification. Even apart from the process area I am LEA certified. I train people on mobile cranes and offshore cranes, even here in the Middle East. I certify them, so I also develop content when it comes to crane operation and lifting. I am LEA certified. So whenever you open a laptop, maybe let me assume that Nicholas is here. He has a link of this. If I just open this, I will see the current document that he has searched. So script does come to check. Yeah, script does come to check like sensors. That's one. But if you don't have the money to pay here, you can start by checking online Google, right? Check Google, but you need to have a good research skills to use that good words in order for you to get that information on that process flow diagram you have. So they are there. I think one of the class I have done on HYSYS simulation, I use crude oil production facility as a case studies, right? We use corn oil process flow diagram, share, total, ExxonMobil, all those guys. We use a lot of them. So all those documents, I have them too. So moving forward, I've showed you the process flow diagram. Now let me go back to the heat and materials uh, sheet. I will need that class recording of the training materials, please. Okay. So this is the heat and material balance. This is the best, or this is the number one process deliverables you can generate from your simulation. Even when we are done with our field design, simulation aspect, because before we can when we go to the field design, we'll not just go direct and start doing our sizing. We'll now complete our simulation because conceptual stage of design or conceptual studies is there for you to develop the process scheme and confirm that you can produce this product with the feed from the scope of work that the client has given to you. Secondly, is for you to now select the licensor which you are going to advise the client to give the feed and detail project to. Understand? So even if you have given that, if your company that has done the conceptual stage has knowledge about PMC, project management consultancy, your company will still be working as PMC in that project. You will now be in between the licensor will not be contractor, and the client. You will not be in between them. Before the licensor is going to send the document to the client, it will come through you. You go through the clients, through the approval, blah, blah, blah. These are the channels, and till you get what you want. So fine. Moving forward, seeing a lot of questions. I will need, I mean for the good oil. Yeah, yeah, yeah. Okay. So, let me start with this. This is intermaterial balance, HMB. We use this document contains process conditions which we get this from our simulation. So these are the process conditions. So whenever you want to size a line, if you are sizing a line, you need temperature, you need pressure, you need the flow rate, you need the density, you need the molecular weight, you need the viscosity. When you are sizing a line, you don't need the conditions or the compositions. You don't need them, right? You don't need all this. But when we are generating our intermaterial balance, we always present it like this. So line sizing, we have what we call line sizing. Let's go back to our simulation. We have streamlines. We need to size our line. We have pumps, we have compressors, we have distillation column. So in this area, we do our preliminary sizing and keep. After doing our preliminary sizing, we'll now go back to, let me assume that we are doing a project for NLNG body. And NLNG body, Share is the one in charge of the operational aspect of an LNG body. And Share is using their code and standard for that. If Share contracts this project to me as Max Engineering Limited, what I'm going to do is I will request for this. This is it. Let me reduce it. Let me minimize it. This is what? Process design requirement. This is the code and standard for sizing, lines, pump, so many things as stated by Share. So you have a lot of things: pipe sizing, piping layout, design conditions, PSV, level gauge, fire water, and so on and so forth, right? So let me assume that, okay, let me just size one line. Now, we want to size the line, right? Let me assume we want to size this line. This, yeah, is it pure nitrogen. So this is how to size line in IC simulation. You click this, you go to where. Okay, let me remove this so it's not block me. So you come over to where are you? Done. Okay, fine. This is it. You come over under this equipment design, you will see line sizing. When you click line sizing, the first thing you are going to do, you come over to append lines. What do you mean by append lines? For you to select that particular stream line, that particular stream, or that particular pipe you want to size. So our aim was to size a pure nitrogen, right? We click it here, we click accept, right? After clicking accept, this is just preliminary line sizing. Now, under this preliminary line sizing, you don't have anything to do with the material for now. You don't have anything to do with the schedule for now, right? But when you are doing fit design, when you now involve your pipe segment, you need to select this pipe schedule. If not, you now have the right line sizing for that project. So this now, what you just need to do is to come over to settings, different company as per their software. What they just need to do is to specify the velocity. Now, as per code and standard, when you are sizing a line, a line that has liquid, a liquid line, there is a velocity criterion range, or there's a velocity criterion we have. When you're assessing a gas line, there's a velocity criteria. When you're assessing a multi-phase line, there's also a velocity criteria. So let me assume this pure nitrogen is in which state? Okay, guys, this pure nitrogen is in which state? Tell me. One is what? Pure nitrogen is in which state? Liquid state or gaseous state or multi-phase state? Gaseous state. Gaseous state. Excellent. Excellent. Good. If it is zero, then it is what? Liquid state. So since it is in gaseous state, when we are I think for gaseous, the maximum velocity in feet should be 60 feet per second, while for meter per second should be around 15 meter per second. So all this is as per good and standard. So let me just go back to what we are doing, that of the line sizing. So what I just need to do here is just to specify. Now this is a meter per second, I'll just put 15. Enter. So it's just going to show okay. When you show okay, I'll just come to my sizing and see here. It's telling me the nominal pipe diameter is what? 900 mm. 900 mm. Please convert it to inches. How many inches? How many inches? Divided by 25, right? Hello, how many inches is this? 35.43, let's say 36 inches, right? Now, this is just preliminary design. Preliminary design doesn't mean that we are going to accept this 36 inches. It's just giving us a guide, right? When we involve pipe segments, and now, imagine now we just talk about velocity criteria. We are not even involving the pressure drop criteria, right? So when you now involve the pipe segment in the first stage of design, you will now be involving what? The pressure drop criteria. By then, I'm very sure this is going to reduce. It's not be that 36 inches we saw there. So this is how to check line sizing. Now, this is just for using the software. Now, let me assume we want to use a template. I'm not using my software that has my process template. I could have shared the template to you guys. But what we just need to do is, let's go to this share standard. Under, what's it called? Here is a line sizing. Under pipe sizing, page 13, right? So under page 13, see here, pipe sizing, right? This is what I'm looking for. I just need to go here. Preliminary sizing. Okay, fine. This is what I'm looking for. They say, okay, let me start from here. Sizing liquid piping system. We have a liquid piping system, you see? We also have sizing for gas and steam piping system. We also have sizing for amine piping system, right? Sizing for drilling piping system. All these sizing depending on the pipeline or the fluid, sorry, depending on the fluid you are passing through, right? But in summary, most of these companies, they generate their standard from these guys. API 14E and ISO 13703. This is American standard, this is British standard, right? I am API certified and British certified when it comes to sizing of lines and equipment. So all these guys are we are like we are talking about book and human is brothers. I am brothers to all this. So we have their details. So if you look at this now, let's start with this liquid line sizing, liquid piping. You will see that when you are dealing with fresh water and brackish seawater, depending on the material you are using, you will have the maximum velocity and the minimum velocity. Minimum velocity for all of them is what? The same. But depending on the material, the what's it called? The maximum velocity is what? Different. So this is where mechanical engineers will now come with the process engineers to discuss as per standard what kind of material should we be using here, putting corrosion into place and other factors into place. We should be using carbon steel, stainless steel, GRP, or copper nickel, right? So this is where mechanical engineers will now come and discuss with you guys and say, this, that is. If it is a refinery guys are building, they will use a standard ASME 31.3 and check the materials which they are going to use. You understand? So all those standards are all there. You don't need to cram them off head. You don't need to cram them in your head. They are all there. So this is it. So imagine if you want to size this line. Let me show you this formula. Is the formula not here? Share did not put the formula. Okay, this is the formula. For top. The formula is here. Let me increase it. Let me now show you where we are going to use our heater material balance parameters. Share said equation 1. I guess this is for ISO, right? And this, okay, ISO. ISO is in what? This is SI units, right? Okay, ISO, this is for ISO. 353.7Q divided by the diameter squared. Why this is for what? API 0.012Q. So now, if your company is using the metric standard is our ISO, while the imperial standard is the API. So depending on what you are using. Now, what you are looking for is the diameter, right? We need to calculate the velocity at different ranges of diameter. So any of these diameter that is velocity fall within the velocity criterion is that diameter we are going to select as diameter for that line. But take notes, see this Q, flow rate, see it here. This is where we are going to get it, mass flow rate. Any line you want to size, you must get that thing from here, right? Take notes. Your mass flow rate must be gotten from your heat and material balance you generate from your HYSYS simulation. You see, this is the technical aspect we are now discussing about. We are done with simulation. Simulation have given our result. What are we going to use simulation to do? Again, there's a chart here. This matter hard for only simulation. Don't worry. Oil and gas is if you involve yourself in the design, redesign, you will feel happy. In the sense that when I mean, the doctors, when they treat someone and the person is okay, they feel happy. The stage I've gotten in my life when it comes to design, when I complete a particular project and see that in the next 6 months, 1 year, 3 years, facility is still running, I always feel happy. Why I always feel happy? Why? It's because of what? Imagine I stated and said use 2 inches and 2 inches is working. I come and said use this pump and this pump is working. That pride, that the energy. I'll be very, very happy that what I stated, what I told them to use is still working. But take note, if what you stated is wrong, you lose your job. Oh. That's one of the disadvantages when it comes to working in this kind of area. You will lose your job immediately. Why you lose your job is because of, imagine you did a design and you are the one that designed it, the senior process engineer checked it, the principal process engineer approved it, and purchased that pump. Let me assume the pump is about $1 million, right? They purchased that pump, and they brought the pump to the facility. And when they start using the pump, within 3 months, the pump is not actually pumping out the expected pressure. And maybe they now contracted that particular problem to another company, and they now confirm that this is not the pump that's supposed to be used for the job. Immediately they just confirm that. The next day, those three men are going back home. Immediately. Immediately. I don't joke. Do you know what is $1 million? Are we joking here? No, 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 no. You just go home, pack your things. We don't want to make such mistake anymore. Go home. So that's that. So this is just for line. Now let's go. A lot of things. This is compressors, coolers, energy heat exchangers. We have our valve, control valve. We also have a standard for sizing our control valve. There's what we call CV. All what we are looking for is what? CV, right? And also this control valve you are seeing here, we also have some gate valve, bypass valve. Maybe want to design this valve as per fade to close, fade to open. I'm not taking you guys into the fit design, right? This is what we now do. You now see that P and ID will now be bigger than this process flow diagram you are seeing here. Because of what? Only this guy here now. Only this what's it called? Control valve you are seeing here will be bigger, will be big like this. Other fittings close to it, right? So I think there's a message. Okay, so please take note. Let's go. We're going for break in the next 6 minutes. So moving forward, so just take notes. I just showed you the line sizing. We also have other ways to size, other things to size. I just want to move you guys to the P&ID. But before I do that, let's discuss about the P&ID in our next what's it called? After our break. So any question? Do you have any discussion? Anything to ask me? I know I've stated a lot of information rushing in order for me to meet up. Any question, please? There's a lot of questions. Abi? Yes, a lot. Is P&ID and PFD the same? No. PFD is just the overview of the what's it called? Of the facility. P&ID has more information than that of the PFD. P&ID is more complex. P&ID is a complete drawing of the facility. PFD is just the overview. That's just a layman definition of it. So, just a lot. PFD is different from P&ID. Excellent. Thank you very much. Let me see. Oh, sorry. I'm not using my erase system to share to you. So please, will you touch on? Someone is asking me if I would touch on the project economics. No, no, no. There's no time for that. Discussing about CapEx, OpEx. We don't have that time. Sorry about that, Gordon. Okay. Especially for me, especially for someone like me who is new to process and petroleum engineering. Victor Carlo, don't worry, you are covered. Don't worry. Is there a reason why more percentage is used to specify composition during modeling and not max fraction? This depend on the what's it called, on the fluid you are using. Sometimes we use mass fraction, sometimes we use mole fraction. It depends on the fluid you are using. Take notes. Depends on the fluid you are using. Is there someone said, is there after training consultation? Excellent. Yes, I think I shared my number yesterday, and I shared the link of the Mass Engineering website, which you can go and also get their contact number. Let me see, share my number again. I have already received some messages, but don't worry. After our break, I'll be giving you guys a lot of information as per making sure that you have the necessary information you want. So they say, I want to ask, what is the typical step for a typical project? What comes first and what follow simulation? Material and energy balance, PFD, P&ID line size, and equipment line size. Oh, see, take note. First is the simulation, right? After the simulation, we are going to generate the heat and material balance. But before we generate, as we are generating the heat and material balance, we are also generating the process flow diagram. So at the conceptual stage of design, you will have a PFD and heat and material balance from the conceptual stage of design. When you move to the field stage, before you do any sizing or anything, you first of all complete your what's it called? Your process simulation. Even if you don't, it's not 100% completion, or let me say about 80% completion. When you have done that, still in that field stage, you start your line sizing and your equipment sizing. Equipment sizing, after doing your equipment sizing, you are going to generate your equipment data sheet. And that's why in a particular project, you see a lot of people involved. As a process simulation, you not be in simulation, be doing sizing. No, 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 no. You'll be doing working with the process control for hazard passing. No, no. We have so many people. You can just be in the simulation. They want anything, they will call you. You also be waiting for updates, waiting for updates, things like that. And we also have people involved in the P and ID. They will take the P and they will get the PFD, take the P and ID gradually, step by step, getting the information from the process simulation. And also, this is just for process simulation, process engineers. Mechanical engineers will also be doing the same thing, right? We want to generate the equipment data sheet. In the equipment data sheet, the materials we are going to be using for this for the equipment, the materials to be used for this equipment will be stated in the equipment data sheet, right? So in that equipment data sheet, mechanical engineers will be there, material engineers will be there to state it. So they also get conditions or parameters or data from the simulation for the process simulation engineer. Understand? So we everything works simultaneously, right? But at the end, at the detail stage of design, we would have completed 100% completed our P and ID design. At the first stage of design, we should have gotten to the stage of 80 to 90% simulation, completed in the detailed design, the remaining 10% in the detailed design. P&ID will be completed also in the detailed design. We will also do our line sizing, equipment sizing in the detailed design, and all those things will start our 3D modeling. 3D modeling in detailed design, even not even detailed design. I told you guys, oh, I've not shared that news to you guys. In the recent, I think from 2024 Aspen Tech versions, we have what we call OptiPlant. We can send this file now to OptiPlant. OptiPlant will automatically generate our 3D model at that conceptual stage. So most time we don't even start designing our 3D model from scratch, right? We don't design our 3D model from scratch. Multiply will give us that overview. Then we'll now come and start changing the necessary equipment, shifting the equipment as per what is stated in the positioning distance of, I think there's a standard that states the distance at which each of the equipment need to be as per maybe low pressure, medium pressure, and also high pressure. So everything works simultaneously. But at the detailed design, we would have completed our P&ID design, right? We would have completed our 3D model, would have generated our piping ISO, would have also done our pipe stress analysis. Structural engineers would have also know the necessary structural support needed for all those equipment and pipes. You understand? So, but first, simulation, PFD, heat and material balance, sizings and P&ID simultaneously. So please confirm if I've answered your question. Adewumi. So I guess that's all. If I've answered you, if there is any other question for now, ask. I guess we should go for break now. So moderator, please, over to you.
Hi everyone, we'll be taking 10 minutes, quickly just stretch, stand up, get some tea, some coffee or water, and we'll be back by um by 10, 11, before 11. Thank you. Hi everyone. I hope we're back refreshed and better. We are going to continue from here. Please confirm you can hear me. All right, thank you so much, Nimisola. So over to you, Majid. Let's take it up a notch.
All right, thank you very much, everyone. So let's see. Okay, I'm supposed to share a P and ID. Maybe I'll use this modern laptop. Oh, not yet. Okay, I just saw one online. I guess I can use this to explain, but not very clear. Let's keep it. All right. So for that of the P and ID, there's what we call piping and instrumentation diagram. So for the piping and instrumentation diagram, we start the piping and instrumentation diagram from the PFD. The PFD is one of the input deliverables required for developing the P and ID. So when developing the P and ID, at that moment, before we start developing the P and ID, as we are developing the P and ID, we have already started the 3D model, right? We are doing both of them simultaneously. So if you look at this line now, see this pipeline or this strip that is here. Now, depending on where this is coming from, maybe through the atmosphere, before this is going to go into this compressor, right? There is going to be some gauges, a lot of gauges, maybe pressure gauge, temperature gauge, in order for us to know the particular temperature and pressure of the air going into the system at that particular time. Because the temperature and pressure of the air going to the system will also determine the operating capacity of this pump. And our aim is to increase the pressure of this air from 101 to 700 kilopascal. So all the necessary instrumentation lines, fittings that will enable us to make sure that this from the air to the compressor one, cooler two, compressor two, and so on and so forth. For us to make sure that everything is working safe, we must fit them here. So when we are doing our P&ID development, we have stages of P&ID development. I think about 30%, no, I think 30%, 20%, 30%, 10%. So at each percentage, there is a required activities that must be done in the full PFD, and it must be approved before we now move to the next stage. So our P&ID has about 4 major stages. I think in the third stage, this is where we are going to fix in all the necessary hazard analysis, all the process safety analysis that has been done in the facility or in the plant. We'll now implement them. For example, now, look at the storage tank, right? Definitely, as we are putting our nitrogen, as the nitrogen is going to here, there is a space. This space, we are going to have some gas. That gas that is there, there's a time it's going to get to that at which we are going to flow it out. So that means as we have this storage tank, we need to put a PSV, pressure safety valve, or pressure relief valve. All depends on the fluid that is inside, right? Maybe in the liquid state or in the gaseous state. So each of these fittings, as per standard, has a specific procedure of sizing and also specific fittings that must be there. We don't cram. When you're working with line sensor, all those things they are talking about is not a new thing. Compressor, there is a basic fitting that must be there. The only new thing you just need to do is to make sure that you size that fitting to be working as how you want it to be, or how you want it. If you look now, let's go to this compressor. This compressor, we are increasing pressure from what? 367 to 700, right? All the necessary valves, gauges around this compressor, we must make sure that they are working as this pressure we are increasing from 3 something to 700. I think there are some questions there. Please drop your, okay. So that's that. So for the P&ID, we have a lot to go. So I don't want us to involve ourselves deeply into the P&ID. So I would love us to start asking our questions before. Okay, fine. If you have any question, you can drop. Now, my advice is that first and foremost, we all need to thank SPE for organizing this. To be sincere, I can't remember when I was in the university. I don't even know maybe if we have such opportunities like this for young graduates to be having all these necessary things, right? So, IESL is advertising processing. What is IESL? Is it the name of your company? Hello? International Energy Service Limited. Okay.
Yes,
I've not heard of them before, sure. So I saw a question. Ogbonna, try to ask your question where everybody is going to see it. So everybody will see your message. So he asked the question, is the term boil off gas appropriate considering the fact that the storage tank is of gas? This storage tank here, the liquid, we are storing this our nitrogen in a liquid form, right? But since we are storing our nitrogen in a liquid form, the dome, the top area, we are not going to store this nitrogen is not going to be 100%. Like the storage tank will not be occupied 100%. There will be a space, right? When we are designing a storage tank, there's what we call low, the medium, and also the high. There is a particular height, maximum height that the liquid in that nitrogen should be. It should not get up to 100%. Why it should not get to 100%? We must keep a space for vapor to be there. So those vapor that is going to be there, those vapor that is going to be there, sometimes we are going to flare them out. Or from that, we are going to recycle them and find a way to convert them to liquid and send them back to the storage tank. Understand? So that's that. So moving forward, uh, as I was saying earlier, another question. We are excited to announce multiple blah 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 for process and that. Okay. Deadline 10 a.m. Now, if you look at this, that is someone posted now. I really appreciate you post this very, very much. If you look at this now, they are recruiting for process engineer, instruments and control engineer, electrical engineer, piping engineer, pipeline engineer. What I would advise you guys to do is that go to each of these. For example, now, okay, fine. If I want to see your specialization, I want to see your specialization on the group. If you're a process engineer, mechanical engineer, please type. Let me see. I guess we should be moving close to the training. Moderator, we have 1 hour left, right?
Yes, less than
1 hour
1 hour.
left.
Thank you.
Okay, fine. So please, I want to see everybody. We have about 24 personnel here. So let me see. Okay, production process operation engineer, fine. Let me see. I want to see your specialization. Or even though if it's not your specialization, if you have not started working, what is your degree? What did you graduate? Petroleum engineer, excellent, fine. I want to see this. Yes, this will determine how I'm going to channel what I want to say now. Mechanical engineer, chemical process engineer, excellent. What else? Petroleum engineer, everybody. Petrochemical technologies, good. Petroleum engineer, process and technical safety engineer, excellent. Petroleum and gas engineer, perfect. Chemical engineer, excellent. Good. Chemical engineer, petroleum engineer, chemical engineer, good. Petroleum engineer, oh, everybody. Petroleum chemical, petroleum and gas engineer, good. Okay. Okay, excellent. So I'll just put it in summary that we have the disciplines I need here. When I say disciplines I need, with respect to what I want to say now, this statement is for everybody here. Petroleum, gas, chemical, mechanical, process safety engineers. There is no what's it called? Please reverse this info for the WhatsApp group. Okay, fine. Thank you very much. Okay, yeah. So see here. First and foremost, let us thank Society of Petroleum Engineers. I don't know, maybe it's because we are not during my time. I don't think if we have things like this, but to be sincere, for the past 4 years, I've been seeing these updates when it comes to technical training from Port Harcourt section. To be sincere, I love this. This is marvelous. This is going to really bridge the gap and it's going to make sure that those people graduating from the university will know what they are going to face in the oil and gas industry. Because if you know what you are going to face in the oil and gas industry, you will now know the trainings you need to do so that you will not stay home for a very long time thinking that someone is doing you from your family. That is why you are not getting job. You understand? Just your own part. I have seen a lot of people looking for job, but you ask them, what can you do in that company you are looking for job for? What can you do? You don't have anything to do. Even if you have an uncle, it will be difficult for that person to recommend you, right? So that is the reason we collaborated and we are doing this training. I'm very, very happy it has gotten to this extent. So if you look at this process simulation now, we have not completed this process simulation. Everybody in this class or in this meeting, based on your specialization, you need IC simulation. Mechanical, process safety, petroleum, gas, chemical, you need process simulation. Now, what I would advise you guys to do is that don't just learn process simulation as per putting temperature, pressure when you don't know what you are putting, right? Try to know this simulation in the sense that when you get a process flow diagram, even without getting any condition from any company or any data from any company, you should be able to move around and make sure that you can achieve that production of that product as how it is being specified in that process flow diagram. If you have gotten to this level in IC simulation, good to go. That's one. Secondly, I will also advise you guys to also move on to the international certification. It helps in the international companies in the Middle West, in the West, in the Middle East, in the West, Europe, they value international certifications, to be sincere with you, because that is going to show that you are certified. Even if you don't know the job, first they want to see that, okay, you're certified. That is going to give you an edge over others when applying for the job. Look at this job now that they say HYSYS is bringing up, right? If anybody that has, for example, now, I and Ogbonna have the same skill, the same experience. I have the international certification, and Ogbonna doesn't have the international certification. Probability at which I'm going to get the job will be very, very high. So my advice is that the reason why we have this technical training is to give you guys the bridge the gap between what you have learned or what you have, the knowledge you have before, or maybe if you don't even have the knowledge before, see what is going on with this simulation software and see what we can use this simulation software to do. This is just conceptual stage of design. Look at how it is. What about the field design? To be sincere with you, just I'm not sharing and I can't share those field design because these are not files I can share like that. I could have shared and show you guys how complex a process simulation design is in the field front-end engineering stage. So in order for you to be able to do this, you need to look for a way and make sure you undergo the training for you to understand what is going on. If you don't understand the training, then don't even bother yourself thinking you'll be applying for a job. Because if you're applying for a job when you don't even know, let me assume you get the job and they say, okay, come on. Not even someone I trained maybe about since 2018. When I was training this guy on drafting, mechanical engineer, he was not even doing any assignments. I think early this year he was chatting me up. He got a job from one company, blah blah blah, this and that. He has forgotten what I taught him. I say if I can remember, when I was teaching you, are not doing assignment now, you're not practicing. So how do you think you are going to remember anything? So now the money he paid then, I think he's paying almost times five now, due to the how things are when it comes to currency and money. He's paying times five. So he didn't utilize what he learned then. Since 2019 and be 18, this is almost 7 or 6 years later. See what is going on. So if you don't invest in yourself now, the probability at which you get that 6 digit what's it called? 6 digit salary will be low. It will be very, very low. Now, I'm even talking about 6 digit. You guys are first. People are looking for 5 digit first. When you look for 5 digit, then you go for 6 digit. Understand? Some people in some industry are already in 7 digit already. Monthly, I work with them. Monthly, 7 digit guys. 6 zeros, yeah, 6 zeros, that's million. Some people are earning 7 zeros, and you not see them doing anything. They are there because of what? What they have. If you look, it says six digits no follow. If you are earning maybe 10 million naira per month, you no follow me. Who is this Ogene Chuku? Understand? So that's that. So I will start with this, what we have done at conceptual stage of design. Max Engineering Limited have a good training course when it comes to conceptual stage of design, front end stage of design, detail stage of design, construction and commissioning phase. Okay, with respect to what we have learned, let me just channel the training you need in order for you to achieve this complete training. If we go to process engineering, I cannot be moving one on one. Let me just search modeling. So if you look at this now, they have what we call process modeling / simulation with using Aspen HYSYS. They also have what we call advanced process modeling and simulation using Aspen HYSYS. Let me start with this. What Max Engineering Limited does is that after they are going to take you through introduction, oil and gas projects as we have done, more in depth because the I think is about okay, the duration is not here, it's about 8 to 10 days until when they complete this module 17. See, finish the stages, application, simulation, the components involved, properties, petroleum assay, which is the crude oil. Because see, in Nigeria now, I don't know if you have heard this update that I think we are about in UK. They did some oil well auctioning that very soon, if this the necessary people that are going to get out buy the oil well license, if they buy from the federal government, there will be about 400,000 barrel per day increment plus what we are producing. That means a lot of production will start, and this well are due already. They just want looking for people that will just build a production facility, get this crude oil, produce it and badge it out to a particular storage area. That's what they are just looking for, right? So if you look at this petroleum assay area, is basically talking about all those areas. So look at the unit set, all those necessary components I told you about, equipment design, line design, and so on and so forth. Modeling simulation of pump, each of those equipment, modeling equilibrium reactors. For those chemical engineers, even the gas engineers, you'll be dealing with reactors. When you start any design you are doing that involve chemical, you involve reactor. We have so many kind of reactor: equilibrium reactor, what are they? Equilibrium reactor, conversion reactor, plug flow reactor, and so on and so forth. All of them have their applications. Pipe segments that I told you will be using in fixed stage of design. Logical operators, modeling, simulation, separation columns for gas engineers. Data material balance, reporting. This is a crude oil project. So they have two case studies. One that is mandatory is crude oil projects. Why is crude oil projects? Based on in Nigeria, we have a lot of production facility or crude oil production facility. That's why this one is mandatory. So after you are done with this crude oil production facility, you on your own can say that you can beat your chest, you can do any simulation on crude oil production. They also have simulation of crude oil plants and so on and so forth. Okay, this is continuation of this. And again, feasibility / conceptual design of gas / chemical projects. One thing that Mass Engineering Limited used to do that I love is that they don't repeat case studies, no matter it is. Because we have so many oil and gas products, chemical products on ground, so many. So Mass Engineering, any training they have a new product, a new feasibility and conceptual design they are initiating to their trainees. And anyone they are bringing up is any feasibility or conceptual design that they are working on is something that is going to be demanding, that is required worldwide. So after then, they will also guide you on how you can get your Aspen user certification exam. This is just one. This is just and I think the cost is even cheap. 180,000 to be sincere with you, is cheap. And this is very, very cheap. Let me not lie to you guys. This is just the process modeling. I will advise you guys, when you finish this, depending on how far you want to go when it comes to your skills, also move on to the advanced part. The advanced part is now talking about unit operations, acid gas process, gas dehydration process, sulfur recovery process, saltwater process, line sizing utility, hydraulic calculations, column operations. They now have another case study again on gas and chemical projects, which is still different from what they have done in the normal one. They will also guide you on how you can now have your Aspen expert certification. 250,000 naira, extremely cheap. Because why I'm saying extremely cheap is because when you get a job, I have trained so many people in Nigeria that they got a job, even in Nigeria there. Graduate process engineers, which I have trained, they are earning the least 550,000 naira, graphic process engineers. 550K. So when they started with 550K, in the next 2 years, depending on how smart they are, they will move them to 800, 1.2, 1.5, 2 point something. That's if you want to increase your money. Some people will just say, oh, 550K is okay for me. I will not learn again. When you learn this one and you are earning such money, still continue learning. As I am like this, irrespective of the level I am still learning. The day you stop learning is the day you are gone. Take note of that. So this is the second one. And again, I will also explain something. Let me assume that for those that have gotten either the user that doesn't want to go for the expert now, there's a training I will advise you guys on. See this training. I think it should be the last part. See this training here. I think someone made mention of something that he wants to have knowledge on, what's it called? Process design using HYSYS, right? See this now. Process plant design and simulation. Let me click this course for you. You'll see how beautiful this course is. Let's ignore the description for now. See, after, let me assume you have knowledge on IC simulation. You don't want to do your expert. Maybe you have your user international certification. So look at what this course is talking about. After introduction, design condition evaluation, process deliverables. We have the oil and gas industry. Process simulation software. You will now choose the process simulation software you want to undergo the training with. They will now teach you how to use HYSYS, or let me assume HYSYS, to use HYSYS software to do line sizing, HYSYS software for pump sizing, HYSYS software for control valve sizing, HYSYS software for orifice sizing, HYSYS software for separator sizing, for heat exchanger sizing, distillation column, for optimization, for PSV sizing, for your process plant designing, for your dynamics, simple, problem, and major problem, for just 500,000 naira. For just 500,000 naira. Look at what you are learning. Look at what you are learning. In the West, I think there was one time when I undergo a training from the United States. 1 hour is $150. 1 hour, $150. 4 hours, $600. 1 hour, 150, 400, 4 hours, 1. Let me ignore that for now. So I think there's some messages here. Hope they will give us discount, sure. Just send message to me, and also either go to the website. From the website, they have a contact number here. Chat this number or send an email to this. They can. And again, there's also an opportunity. If you don't want to undergo the training with everybody, you just want to receive the link for you to undergo the training. If you click enroll now, put your name, put your email address. When you put all these details, you proceed to payment, you receive your payment. They will receive the information and they will send you link for your training. And when they send you link for training, it doesn't mean they will just leave you like that. Though. They will still be calling you. Do you need a 1 or 2 hours physical explanation from your questions as per what you have undergone? They have such. So this is just not only process engineering. For mechanical engineers, I told you guys, mechanical engineers work with the process engineers. Under the mechanical engineers, you see so many courses. Let me assume that you have a course from your own end that you want to undergo. See, pipeline engineering. AKK project is here. A lot of pipeline project is coming up. See? Pipeline, blah, 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 this and that for just 150K. I even discussed with the management of Mass Engineering Limited that the money for their courses are too low, extremely, to be sincere. Because some of these courses are 5 to 10 days training, not just 5 to 10 days training. They do their training in a way that they make sure that the participants understood all the necessary course outline and the learning outcomes of the training before they can say, okay, good to go. And each of their training has their case studies, which they will now involve the real life scenario of what is going on in the oil and gas sector to that course you are learning. So what I would advise you guys is that we don't really have that much time, but at least we thank Society of Petroleum Engineers to give us that opportunity to show you the technicality of this IC simulation, what we use them for the projects. When we are talking about engineers, we're talking about projects. What we use that software to do for design, for solving problems, for supervising, troubleshooting, making sure that you have the right facility on ground. So please, I already received some messages as per the training, and for this particular design, I think next week Sunday or next week Friday, Mass Engineering Limited is starting a training on IC simulation with a case study of air separation unit operation. So that case study of air separation unit operation, this kind of simulation will be completed. They will now bring 3 or 4 line sensors, simulate those line sensors process flow diagram, and compare with cost, products, and all the necessary things we are going to compare to make sure that, okay, fine, let us contract this project to this licensor. So next week Friday, the training on IC simulation for this is starting. And if you are interested, I've already seen some messages already. I told them to hold on. Some of them already requested my account number. I told them to hold on. Please hold on. Let us finish this section before we can start talking anything about training for now. So please, do you guys have any question with the technical training we have done, or with also the website I shared to you guys? That we don't have much time. We also have courses on HYSYS, project management consultancy, pre-commissioning. I think they have about 325 courses online here. They also have courses on, let me show you one course. See this course, refinery instrumentation. Okay, this one, refinery valves, accesses and control, and control and safety instrumentation system. See this, what is it called? See this control valve that is here now. That course has to do with this control valve. All the necessary P and ID you need to fix up here. The gate valve, the ball valve. You need to confirm maybe it is a fail to close, fail to open. How many drain valve you are going to put here? That course will give you that knowledge. And again, one thing I'm supposed to share again, which is important, is here P and ID development. See, Mass Engineering Limited have 4 courses. They have P&I Development Procedure 1, Stage 1, Stage 2, Stage 3, and Stage 4, right? See these 4 stages. If you have gotten to a stage whereby you know your IC simulation very well, you want to learn about P&I development, this course is going to give you a good knowledge on how to convert this process flow diagram to P&ID. These 4 courses. They all have different course outlines. See, 29 chapters. When you finish, you see pump and compressor. If you want to design the P&ID of pump and compressor, everything is here. Filter, tank, valve, see the valves. Everything is here. They also have for P&ID development too, different outlines. See, about 21 chapters. So that's why I am angry with Mass Engineering Limited. Be sincere. I've discussed with their management. How can you be doing P&ID development and you are paying 180,000 who does that? So, but all is well. It depends on them. But to be sincere, I would just advise you guys to all to grab all this necessary opportunity, because company like this will just use a small money for all this. In the period of time, you just be seeing a big money. So can you please reserve your own hangout, make me learn big group. So please, any other question? Do you have any question with respect to what we have learned so far? If not, I think we have about 18 minutes. Let me hand over to the moderator.
I want to ask the how do you convert the PFD to the PNID using Aspen HYSYS? And also you made mention about sending your diagram to AutoCAD and printing it. You said you show us how to do that. So I really want to know about that. And what is the importance of the AutoCAD? Why are you sending it there? So that's just my question.
Okay, fine. Let me answer that last. No, let me answer the last question first. Why it's important is because there's what we call process deliverables. When you are doing a project at a particular stage, deliverables are documents, right? You will generate documents. This document you are generating is for you to use it for another project or for another phase of that project, right? So this PFD, we need the PFD for the P&ID design, right? So for that I'm sure I've answered that question. Let me just summarize all of them. If you want to convert your your IC simulation from here to AutoCAD, you just right click, go to print PFD to file, go to I think print DXF file, then you have it here and save it. See the one we save already. You can name it. So it is in DXF file. I train people on 3D modeling. Whenever we are done with our 3D model, we want to generate piping ISO. The piping ISO is always in TXF file. So that piping ISO, we can also do all the necessary thing we want to do in the draft part because the PDMS have PDMS design, PDMS ISO draft, PDMS admin, and so on and so forth. So in this PDMS draft area, what you can do in AutoCAD, you can also do it there. But it's a bit complex for some people. So that's why people just, after they are done with their piping ISO, they will just convert that drawing to AutoCAD, which is easy for them, and do all the necessary drafting, send the drawing to the company templates, and they will print. So, hope I answered your question.
Yeah, but you have not answered them. How do you convert PFD to PNID using Aspen HYSYS?
How do I convert this one to P&ID, right?
Yes,
Oh, how you convert your process code diagram to P&ID involve series of
processes.
processes, steps, and so on and so forth. It is easy, to be sincere, when you work in development of P&ID, you just be happy. But it is easy. What you just need to do, see this, undergo this training. If you have gotten to a stage whereby you already know what we have done already, undergo this training. P&ID development one. The first one is at 120,000. No, now, wait a minute. The second one is what is how much? 180,000. Wow. This one is how much? 180,000. The last one is 150,000. So
Sorry,
altogether, or maybe 600,000 naira.
no, some of us are coppers here, and if people can establish like a scholarship for us, it will really go a
That is
long way.
why I'm going to advise you to just rush it up. Abibi, sorry, I'm using the Middle East language. Abibi, P&ID development one, we are talking about $5,000. $5,000. They say, what about, someone asked a question, what about how to generate PFD using HYSYS only? Rather than saying, yeah, I think we can do that. It's easy. Here is it, safe. Here is that format. I think we'll come over here, come to, you see, print PFD. Yeah, just name it. When you print PFD, name it, click save. When you click save, come over here, I guess you are going to see it. What did I even use to name itself? FDH. That one is very, very easy now. This is it. But what you need to do, there's how you can just arrange it so that this one that got off here will not be out there. But that one is easy. Sorry, I didn't bring that up. One is easy. There's how you can just increase your file, kind of right click, just click print PFD and name it. When you name it, yes, say yes. What is it saying? Also done. Let me see if I will name it. No, let me do it again. Okay, so that's just the process because of time. And another question, after undergoing this training, are we 100% sure of getting jobs with them? That's a very good question, Shia, to be sincere. Before we start the training, I don't know if you are here, patient Ogo. I use myself as an example. In this life, a lot of people have that knowledge. They don't have the job. Anything we are doing in life, definitely, first is God Almighty. To be sincere with him. It's not by our power. But the part that is by our power is doing what is required. Making sure you have the skill. When you have the skill, you don't have a job for like, when you're applying for a job for 3-6 months, you don't have a job. Alas, the job will come. But when you don't have the skill and you're looking for a job, that's another thing now. You understand? So me on my own, I can't assure you for job. Okay, no. The last HYSYS training I did, there was one guy working in is it SIPCO or what's the name of that company in Lagos? SIPCO that has a facility in Akwa. So one of them joined us in the training. And in that training, the guy brought an update that they are what's it called? Recruiting for graduate process engineers. Then I told him, I think he's also from Yoruba from my end. I called him, guy. One of the things I love doing is that when I see that my trainees get a job after I'm done training them, I push him to make sure that he collected their CV for what's it called? To submit, and they called their phone for interview. When they called their phone for interview, I think they are looking for only one person, and they picked one person from my trainee. And the other three that they didn't pick, they even called me and told me that they made a mistake from question they asked them. And the question they asked them is just because of their shaking. They already know it from the training I've done with them. But this other guy which is smart, got the job. And they started with a big money. He's living in Lagos. The company is not far from there. And he's starting as a graduate process engineer, building his life. I say, guy, just go there, continue learning. In the next 4-5 years, don't worry. We'll bring you into the West, Europe, or Middle East to come and get your 6-7 zeros. So I guess there's another question here. So Princess Ogo, that's it. Just do your part, the job will surely come. They say, what software do we generate 3D model with using output from it? It's OptiPlant. I am also Aspen Tech OptiPlant certified. It's OptiPlant. We use OptiPlant for that. So that's any other question? I think we just have 10 minutes. I guess our moderator have a lot of things to do. Please let's give the moderator time.
All right, thank you so much. It's been such amazing time, really. So much to hear, so much to plan towards. And I do believe that everybody is what is necessary. Thank you very much, Mr. Majid. Thank you very much, Max Engineering. If this course has been beneficial to you, just quickly put in the comment section. Thank you so much, Mr. Majid. Also, just before we wrap things up, do we have any questions? Actually, this training is supposed to end by 5. Well, everything is supposed to end by 5:30. So we can still take a few more questions if you have any.
Okay, I guess there are some questions. Let me just answer them. Tai asks, what course recommended for process engineering track? When your next training facilitated by you? Okay, most of the training I facilitate them. We also have engineers too that are certified too. So let me explain this to you guys. If you are just a graduate, you are going to start as a graduate process engineer. Starting as a graduate process engineer, you should know how to draft PFD and P&ID. You should know how to use 2D softwares, basic. These 2D softwares, you as a program process engineer, as the project is going on, you will be the one using your AutoCAD or any drafting software, Microsoft Visual, any of them, to be drawing the P&ID or the PFD. So after then, this graduate process engineer, when you now move to the process engineer, you should now have knowledge of process simulation, right? Sizing of lines, pumps, process equipment, and so on and so forth as a process engineer. So you should have HYSYS simulation. You should know how to use HYSYS simulation and be certified with HYSYS simulation. Please, I beg you guys, don't leave that certification. You should be certified. So, but learn it very well before moving for the certification. So when you have learned HYSYS simulation, I always advise people to also get a knowledge of 3D model. You will not be the one doing the 3D modeling. but you will work with the process engineers. Sorry, you will work with the 3D model engineers when doing the 3D model. So this is it. If you can contact Max Engineering Limited, Max Engineering Limited can also outline courses for you to undergo, a plan for you based on your specialization. But for process engineers, I think almost everybody here, based on what you guys have stated, if you have done AutoCAD, fine, good to go. Autodesk, I think Mass Engineering Limited is Certiport certified and also Autodesk certified. They can also guide you in getting your international certification from Autodesk. I think Mass Engineering has make sure that almost about close to 150 of their students have passed Autodesk exam. For IC simulation, almost close to 50 of their students has gotten HYSYS user certification and expert. So as Mass Engineering Limited is one of the best area for you. So when you do your IC simulation, then the next thing is what? Line sizing. Let me take you to this area. Under here, there's what we call sizing. Now, under this sizing, you will see basic line sizing. This course is free, to be sincere. This is liquid line sizing, right? This is control valve sizing, gas line sizing, and multi-phase line sizing. When you are done with your simulation, learn line sizing, gas line sizing, multi-phase sizing. Not this sizing, you are going to teach you how to use this sizing with software and also with templates, just like what's it called? Share have. But they don't use Share. What they use is this standard, ISO and API. They use these two standards. So that why they are using this standard is because anywhere you find yourself, all these multinational companies get their standard from these two guys, British and America. That's all. Even though SOC, Norway, you get their standard from them. Nothing is different. There is no difference between these two guys. It's only the unit aspect, right? Because of the unit aspect, you'll be seeing this conversion factor is different, but they still have their flow rate, diameter, velocity, flow rate, diameter, velocity, all the same. So I guess that's that. What else? I'm seeing some questions. Okay, just thank you. Okay, fine. They say, please, sir, why don't you use PrisCAD over AutoCAD? Although I was taught how to design P&ID on PrisCAD, and when I tried, using AutoCAD, some of the commands were different, but the output were the same, though I prefer PrisCAD. Depending on the company I'm using, depending on the company you're working. And also, depending on the clients you are working for, we also determine different software. I use a lot of CAD software. As I told you guys earlier, I don't design anymore. I don't do simulation anymore. What I do is just what? Check. After that, I'm done with the design. So even this AutoCAD I just mentioned, so I can't even remember when I used AutoCAD. But to be sincere with you, if you bring any of the software to me, I will design very well with it because I've used them like very well for different projects. Someone said, what of ASME standard? ASME standards are not basically for sizing lines. You can see, okay, for example, now, if you go to ASME 31.1 and 31 for process plants, 31.3 for refinery plants, when you go there, you see details of also their what's it called? Their velocity criterion, pressure drop criterion for. But one thing I would just advise you is that whenever you have a project to do, the client you are working for, will give you, or they will specify the code and standard you will use in the scope of work. Take note of that. They will specify the code and standard you use in the scope of work. So don't store yourself much about it. So depending on what they give to you, they can't give you anything that is wrong. Depending on what they give to you is what you are going to use to work. But to be sincere, all these standards, they get it from any American or British standard. So that's that. So any other question? Network is breaking, can't hear you. Oh, sorry. Can you guys hear me now?
Yeah, I can
Yes.
hear you
Okay.
loud and clear.
Okay. What about the explanation I made on ASME? I think that he was maybe it's from your own end. I guess my network is good. But I'll just recap again. We have ASME standard for different ASME standards are a bit different from this ISO and API. ISO and API are just talking about specific. ASME standard are talking about the facility, right? We are talking about ASME 31.3. We are talking about the full refinery plant. Yes, all those ISO API, maybe 100 pages. We are talking about ASME, we are talking about almost about 2,000 plus, 3,000 plus pages. So these are contains both the process, structural, electrical, mechanical, the criterias when you want to be doing, when you are doing the design, when you are constructing, selecting materials, commissioning, you're inspecting, anything you want to be doing as per ASME standard. But all these ISO and API I just mentioned now are specific. Specific. ASME, they are broad. So any other question?
Thank you very much, Majid. Any questions? Okay, I want to assume we're all good. So very quickly, we'll be doing something just to commemorate the end of this training session. We'll be taking pictures, right? And what I want you to do for me is really simple. I would want us to turn on our videos, saying that we've not done that, since the start of this training. If you don't mind, please turn on your videos. Let's quickly take pictures. To start, I show you my very beautiful face. You're welcome for the privilege. Hi, Ochiko. Hi, Simisala. Nice to see you. Nice to see you. Hi, Olusegun. It's good to put a face to the name.
Beautiful face. Hi.
Hi. Alrighty. So to enable us take pictures, please could you stop sharing your screen? Let's quickly just take pictures. Right. I'm trying to do that real quick. Okay, so let's do this. Oh, hi,
The
Majid.
heck?
Okay, great. I'm trying to see the best layout that would make things better for us. The current layout I'm saying is not the best. Give me a minute to sort that out. Let me work on my layout and then take a picture. Okay. Wow, some people don't want to show us their faces. Pere is not, his camera is not on. Tejuri, your camera is not on. Tochuku, your camera is not on. Victor, your camera is not on. It'll be nice to have everybody's face show if you're in a good place to turn on your camera. So I'm just going to give us a few minutes to just put ourselves together because I want this to be, your landmark picture of when your career in process engineering begun. Okay? Ogene Tejiri, Tochuku, Ubong, Emanuela, let's give you a few minutes, precious. Just a few more minutes to turn on your cameras. We just want to see your face for a few minutes and then we'll turn it back and turn it right off. Hi, Adriel. Come, hope my video is showing. Hi, precious. Okay, great. So just Tochuku, Tochuku is up. Winifred, Ubong is up as well. Wilfred, and then Tejuri. All right, so I'm going to take a snip of this page. So SP, wait, pause. Let me take a video and then take a picture. Okay, so I'm going to take a video now. All right. SP.
Solutions.
Wait. Yeah, now let's do that again.
Okay.
You're laughing at me. They will not laugh at you, Simisala.
SP solutions, people, energy.
Energy.
Give a nice smile, give a nice smile, give a nice smile, give a nice smile. So I've done a video now.
Thank you. Thank you. Thank you. All right.
Okay, so now let's take a picture. Right, I'm going to take a picture now. This is so dramatic. Give me a minute. Okay, so all people are ready for a picture because picture we are taking next. Give me a minute. Just smile for the camera. Be nice. Sorry, Mona Nuves. It's the enter video, so we're gonna take a picture again. People are laughing at me. I don't like it. Is this what they taught people in the class? We're taking a picture this time. A picture. Like you can't give up on me. You can't. All right, smile for the camera, everybody. Okay, I took a picture. Yay, we won. Blessed be God. All right, thank you so much, everybody, for your time. I do appreciate it. If you have any further questions that have not been addressed in this call or on this call, please do well to also drop a message on the group as you go through the recordings. As you go through the recordings and you figure things out on your own, please do well to reach out. It's also okay if you want to partner with people on the group for, a better experience. That is why we are here. Thank you very much. And then if you want more advanced courses, check on Mag's Engineering's website for further details. On behalf of my committee chair, Nicholas, who is unavoidably absent, I want to say thank you to each and every one of you for joining this meeting. And I do hope you enjoyed it and you had value for your time. Special thanks to Mr. Adeyemi Abiodun Majid for his time, despite his busy schedule, taking out a few hours of his week to have this with us. We do not take it for granted. And I'm putting a word out on behalf of my colleagues that will take this and will do great with it. And in a few years, you'll be proud of what you've set up in the hearts of many people on this call. On behalf of the section, we say thank you. On behalf of the YP chairperson, we say thank you. Thank you, everybody, for your time. Do have a wonderful day ahead. Happy weekend and Merry Christmas in advance. Thank you, guys.